So in section 8.4, Foundations of Math 20, we're talking about scale factors again, but we're going to talk about areas and other dimensions of two-dimensional shapes. So when we talk about scale factor, that scale factor is for dimensions of objects. And so, if a length is x and the representation has a scale factor of 2, then the length on the diagram, whatever, would be 2x, right? Times 2. But when we talk about area, there's a little bit different relationship. Okay, so it's not the same as just a straight dimension. That's one of the things we're going to talk about. All right. So, quilting is as old as ancient Egypt, if you didn't know that. I'll have to tell my wife that. She's a major quilter. For most of its history, however, quilting was used to make clothing. Pieced quilts made by sewing pieces of fabric into blocks and then sewing them together is a more recent development. Norma's making a quilt by sewing together congruent. Now, you know what congruent means? Congruent means identical, the same measurements, okay? Same size. Congruent pieces of cloth. To create a larger quilt, she sews together more congruent shapes. She makes sure that the large quilt is similar in shape to the original quilt. Okay, so the question is, how does the area of the larger quilt relate to the area of the original quilt? So that brings us to the fact that we need to take a look at how are areas of similar triangles or similar rectangles, how are they related? And so over here on the right, we have areas of different formulas, or formulas for areas of different shapes. So you're going to need to know all these. So these are ones that you have learned in your past. Maybe trapezoid. I don't know if you guys learned about the area of a trapezoid before. It depends on what math classes you've taken, maybe up to this point. The area of a trapezoid is 1/2 the height times the sum of A and B. So, yeah, you can. We won't spend too much time on that right now, but you can split this into a rectangle and then 2 triangles. You can do all sorts of different things. You can make a parallel line right here and take this triangle and then bring it over to this side, and it just becomes a big rectangle. So anyways, so it works out that you add up these two, and then you multiply by the height, and then you cut that in half. Okay? And yeah, like I say, now's not the time to go into that, but think about it this way. If you had 2 identical trapezoids, and you flipped it over, okay, how can I do this? If you flipped it over and put them side by side, sort of like this or whatever, then you would have a really big rectangle. And so the area of that really big rectangle, it would be exactly twice the area of one of the trapezoids. So anyways, that's a little aside. But you do need to know these. So spend some time while you're doing this section, or at least between now and the exam. Make sure you know all the formulas for these shapes. Okay? But let's take a look at just the rectangle example, so kind of like the quilt example. So if we have, and maybe you can write this down for kind of one of your examples. Example 1. So if we have a quilt, and let's say just a rectangle here that is 4 by 3. Okay, and the units don't matter. 4 by 3. And if I have a similar rectangle, okay, whoa, that line is a little bit wonky. A similar rectangle, and let's say the scale factor is 3. So what are my dimensions if the scale factor is 3? What's this one down here? 12, right. So you just multiply by the scale factor. 12 and 9. Okay. All right, so the scale factor is 3. That's great. For the dimensions, what about the area? So what's the area of this one? 12 units, right? 12 square units. And the area for this one, what's 12 times 9? 108? Is that right? 108? Okay, so units squared. So the question is, we know that the individual lengths here are related a certain way, and this is times 3. But what about the areas? of a rectangle. So 12 to 108, what factor is that? Yeah, it's 9, right? 12 times 9, right, is 108. And it just so happens that's one of our dimensions, so we know that. And so look at this, very interesting. So the scale factor is 3, but the factor between the areas is 9 for a rectangle. Okay. So let's take a look at another quick example. Let's take a triangle. Okay. Let's take a triangle here. So the height here, let's say, is 5. For this one, let's make a bigger triangle over here. And the height over here is, well, let's do 15. Let's do the same scale factor. Okay. So this is 5, this is going to be 4, and this is going to be 12 over here. Okay. So the dimensions are, again, scale factor times 3, right? So what about the area? Let's see if, what's the area here? So area is 1/2 base times height. So that's going to be 1/2 4 times 5, which is 10. Over here, 1/2 base times height. That's going to be 1/2 12 times 15. And what do we got there? 90. Okay. So, how do we compare the areas again here? Well, do you see how this is times 9 again? So, if this is 3 to the 1, 9 is actually 3 what? To the power of 2. So 3 to the 1, and the area is 3 to the 2. Now, don't write this one down, but just so you don't think I'm totally making this up here with the same scale factor, let's try different scale factors. So don't write this one down, just watch. So let's say, well, we can keep these, I guess, 5 and, what was that one there? Sorry, 4? Okay, so let's do times 4. So we'll get 16 and 20 here. Okay, so if we change those numbers here, what's the area? That's going to be 160. Does that sound right? Okay. So scale factor is now times 4. And 160 compared to 10 is times what? Times 16. So do you see how we're coming across a pattern here? The area, we're talking about scale factor, is actually the square of whatever the scale factor is when we talk about area. Okay, so in a few different examples there. So let's just write that out as so if the scale factor is x, this means that the corresponding dimensions of the original or the actual to the diagram or the representation, you multiply the dimensions by x to get the new dimensions, right? Always times x. That's the scale factor. So that's for dimensions. Areas of the same two objects are related by a scale factor of x squared. So that makes sense, I think, if you're thinking about area, right? It's square units. So the relationship is x squared. And we did a couple examples up here. Okay, any questions so far? Okay, so let's just say I have some crazy object here, and I also have a representation of this crazy object. That's the exact same shape, but it's a different size. So if the area of this one, let's say, is, I'm going to say it's 79.2. Okay, so write this down. It's kind of example, whatever this is, 3. Area is 79.2. And the area of this one, okay, is 212.1 units squared. What's the scale factor? Okay, so see if you can figure that out. What is the scale factor? And don't shout it out when you get it. Let the others try and figure that out. See if there's a way you can do this. So those are the areas, See if you can figure out what the scale factor is. Okay, so the ratio between the areas here we found was 212.1 divided by 79.2, which is this number right here. And because of what we said above, the areas are related by the square of the scale factor. So if this is the square of the scale factor, we take the square root, and there's your scale factor. So if you're given any dimension on the first one, you simply multiply it by the scale factor to get the dimension on the next one. Okay? So if this is 10, you shouldn't even need your calculator to find this right here. What's the length of this side then? What's this one? 16.3. Multiply 10 times the scale factor. Just move the decimal over one spot. Okay? All right? Any questions at all about this section here? Okay. So this is 8.4. And we'll get back to the textbook here. Make sure you remember to memorize all of these area formulas. Okay, it shouldn't be too difficult. Maybe the trapezoid is the first one you need to spend more time on. Okay. So I'll take a moment to look at the key ideas here. Right there.
It's not coming to me. Practice. Oh, really? He does that. What? I didn't know there was a game. This is like a feeling one. But it's a good test. I think it
You guys get to work on your math.